Okay, let's look at the flow of refrigerant through an orifice tube system. So a couple of big things we're going to notice on an orifice tube system versus the TXV system is we no longer have the expansion device right at the inlet of the evaporator. We've got rid of the receiver dryer and we've gone to an accumulator. So remember the four events we have in an air conditioning system. The first one we're going to look at is expansion. So the difference coming now, we no longer are coming from the receiver dryer, but we're coming straight from the condenser into the orifice tube. Remember, the orifice tube is a fixed orifice, which means it is non-adjustable. It's going to spray the same amount of refrigerant into the evaporator on a continuous basis. Remember, on the TXV, we were able to control the temperature of the evaporator basically by controlling the size of the orifice. On this system now, according to your module, in order to control the temperature of the evaporator, we're going to shut the compressor off and on. So it's referred to as a clutch cycling orifice tube system. So coming from the orifice tube, we'll have the refrigerant comes in. We now go through a orifice. So remember now, as soon as I go through an orifice, I'm going to see a pressure drop. So coming in again will be a high pressure, high temperature liquid. Coming out will now be a low pressure, low temperature liquid. And now it will continue down and into the evaporator. Now, just like we saw in the TXV system, coming into the evaporator will be a low temperature, low pressure liquid. It'll go back and forth through the evaporator and gain heat energy. We're going to get what we call latent heat of evaporation. Remember, latent heat of evaporation is a change of states with no change of temperature. So I'm going to go from a liquid state to a gaseous state, or a vapor. So again, just like we saw on the other board, you're going to notice in the center here, you're going to start to see half liquid, half vapor. Again, now we'll continue back and forth through here, and we're going to gain some heat energy after we've gone through the state of change. So in other words, we're going to gain some superheat. Remember, my greatest exchange of heat energy takes place from my inlet to my latent heat of evaporation, also referred to as hidden heat. The reason we refer to it as hidden heat is there is no temperature change. We don't know it's gained heat energy. The only way we know we've gained heat energy is by the fact that it's changed states. So now coming out of the evaporator, should have a low temperature, low pressure vapor. Now, the downside with the orifice tube system is, could we run a flooded evaporator? What I mean by that is, because I'm not able to meter the amount of refrigerant going in, I can have so much refrigerant going in here on a cooler day that the state of change does not take place here. And I actually have a liquid coming out. Now that's why we've added the accumulator. The accumulator now is on the outlet of the evaporator. And your module says, if you look for this evaporator, you'll find it's mounted very close to heat sources, such as exhaust manifolds, turbochargers, and things like that. And the reason being is, we now can make sure we get a complete state of change taking place. So there is only vapor headed off to the compressor. Remember how this works? Liquid would now come in and drop to the bottom, and as this heats up, the gas would rise up, and we now would pick up the vapor and head off to the compressor. Just like the receiver dryer, it's going to filter, it's going to remove the moisture, the desk period, and it's a storage container. So you'll notice a sight glass on the side when you have a look at this board, and you'll actually be able to see the amount of refrigerant flow. So again, now going into the compressor, we have a low temperature, low pressure vapor. The compressor again does two things for me. One, it's going to pump the refrigerant through the system, but the biggest thing it does is actually raises the pressure. And by raising the pressure, we raise the temperature of refrigerant. And now we were able to give up that heat energy quite easily to ambient air. So that means coming out of the compressor now, we'll have a high temperature, high pressure vapor. And it goes into the condenser. And as it goes back and forth through the condenser and ram air, or the condenser fan, as I mentioned before, pulls that heat energy out, we get latent heat of condensation. In other words, we go from a vapor back to a liquid. So we have a change of state taking place with no change in temperature. We have that hidden heat again. So as you look at the board, you'll notice again now that you'll start to see vapor and a liquid. And as it keeps going back and forth through the condenser and keeps giving up heat energy, we'll get what we call subcooling. We're able to give up heat energy. Subcooling is a change in temperature with no change in pressure, which means now coming out of the condenser, and you guys will be able to see on the bottom too if you have a look at this, we should now have a high temperature, high pressure liquid that continues off and onto the orifice tube. Now, this is also maybe a good time to talk about a really cool thing happens in air conditioning systems. One of the best troubleshooting tools we have is your hand. And we know we've always taught you never use your hand as a troubleshooting tool. But the cool thing happens in air conditioning is the fact that anytime I have a restriction, you've already learned this, if I have an orifice, I get a pressure drop. I have a pressure drop in the air conditioning system, I get a cold spot or a cool spot. And on a really cool day, you might see frost forming. So you get an air conditioning system, comes into your shop, and the operator's complaint he doesn't think it's working very well. The best thing you can actually start to do is go through the system, all the way through the system, and check your temperatures with your hand. And you'll start to get used to the fact that what should be hot and what should be cool. Now I'll just throw it out there. If I start coming across here and I've got warm and all of a sudden I get a cold spot, could we have a restriction right here? Or I could have a restriction here. So really cool thing about air conditioning is it self-diagnosed some of its faults. The other thing you'll notice when you get a restriction is your gauge readings will drop down.